So this first one, function f is defined by this. Show that f inverse exists. Now, show that f inverse exists. We already established that f inverse will only exist when f is 1 to 1. You need to show f is 1 to 1. Because then you can only be sure your backward trip is also a function. Okay. So what we're going to do is actually just very simply draw this graph. I will usually complete the square because I don't really like my. I actually, develop the habit to complete the square. I really don't like it when it's not completed the square in the quadratic equation. It's very ugly. This is it. Then try and train yourself to draw the quadratic curve without using a GC. Okay, so you see, this mean point. This is a mean point of -1, 2, right? This mean point will be okay. Try not to use too much of your GC lah. It's really not that good. Then this is 2. This is x. Okay, so 1-to-1 function, you use horizontal line test. So what you do is, since the line y equals to a real value, any of the horizontal line cuts f at most once by horizontal line test, f is 1 function, thus f inverse exists. So that's all you need to know. Am I okay? Not going too fast, huh? Okay, Okay. Great. So I've done this, shown this really. Now, you need to find f inverse x. Okay, so in secondary school, when I ask you to find the inverse function, you just make x a subject. It's the same concept. Okay, so in this case here, you need to make x a subject. So to find f inverse, you just let y equals to x squared plus 2x plus 3. But like I said, you can't make x a subject like that. Okay, you make it the subject by completing the square. That's why you make it completed the square form. Completing the square form can combine two of the x square and x term together. So that's why you make it completed the square form. That's the reason why completed the square is so important. So once this is done, we put y minus 2 equals to x plus 2. My whole goal here is to make x a subject. So x equals to minus 2 plus y minus 2, or minus 2 minus y minus 2. This is important. This part here, you need to know which one to reject. Okay? Because it's a function, it's 1-to-1. You cannot have two outcomes. You have to have one outcome. You cannot have two outcomes, so you need to reject. You reject based on the virtue of this domain here. You are given x has to be less than -1. Okay? Now, okay, some students have this problem here. So you know the difference between do you all know the difference between y squared equals to x versus y equals to square root x? Yeah, which one have plus minus? This one. This is always positive. Okay, this one means y can be plus minus root x. This means just positive. Take the positive, okay? So in other words, right, you talk about this. This is always positive. This means this is always, this square root ensures that this is always a positive function. Okay, then because this one have to be less than -1, so you reject this. X has to be less than -1. Did I do wrongly? Yeah, I did. This is 1. I copied wrongly. Okay, good job. So this one here, I reject this one because I need it to be less than 1. So hence, x is equals to -1 minus. This is your inverse function. This guy is arbitrary. This guy is arbitrary. So our inverse function, we make it as f inverse x. Okay. So we change this to -1, x minus 2. It's arbitrary because now we just swap this y here to x. Okay, we usually, I mean, you can write as fy like that. It's not wrong. Okay, it's f inverse y, but because this is arbitrary, we usually write it in x. Okay, so then this will just be, you want to write the domain. This guy can be any number, so you can just swap. Okay, any question first so far? Okay. Domain of f inverse is the range of f. Range of f inverse is the domain of f. Okay, so this case here, range of f is 2 and beyond. Domain of f, which is given. Okay, there you go. Yeah,